Hey folks, welcome to this episode on quantum numbers, and we're going to put this stuff into practice. So just to review, we have our four quantum numbers. Remember that our first three represent the orbitals. Our last four talks about the electrons that are found in those orbitals. So our first one is our principal quantum number, and it talks about the size and energy. Remember, as we go bigger into a higher quantum number, from 2 to 3, our energy and our size gets bigger, and we call these energy levels or shells. And number 2 is our angular momentum quantum number, and these are talking about our subshells or orbital shapes. Remember that we have our S, P, D, F. S is spherical, P are kind of dumbbell shapes, and D are clover leaves, for example. Number 3, they're talking about the orientation of our different orbitals. And again, these values, ML, can be from anywhere from negative L to positive L. And finally, when we talk about the electrons in that, remember that Pauli exclusion principle says that no two electrons can have the same quantum numbers. And so as a result, we give one a spin in the up direction, we give one a spin in the down direction. So this is a nice way of just organizing your energy levels. Remember that not every energy level will have every type of subshell. So for example, in n minus or n is equal to 1, you're only going to have an L value of 0, and you're only going to have an S orbital. But for some of the other ones, when you get into higher energy levels, they can have more than one subshell. So remember that you have to figure out your L value in order to tell you which subshell you have. So if your L values are equal to 0, 1, and 2, for example, and n is equal to 3, you're going to have, for energy level 3, you're going to have D subshells, you'll have P subshells, and you'll have S subshells. Again, to figure out the orientation, we have to use our ML value. So remember that ML is equal to negative L to positive L. If L is equal to 0, the only value you can have here is 0. Again, each orbital, kind of represented by this box, can hold two electrons, one in the positive direction and one in the negative spin direction. When we look at P, remember that our L is equal to, L in this case would be 1. Our ML would be negative L to positive L. So we'd have positive, 0, and negative. And each of these orbitals, again represented by this box, would have the capability of holding two electrons, one in the positive spin, one in the negative spin. So you could have a total of 6 electrons. Here you have 2 electrons, here you have 6 electrons. And then you can keep going into the D and F's. Here in F is equal to 3, L is equal to 3. So in this case, ML would be equal from negative 3 to positive 3, or positive 3 to negative 3. So you have plus 3, 2, plus 2, plus 1, 0, minus 1, minus 2, minus 3. Again, each of these orbitals could hold 2 electrons, one in the positive and one in the negative. So our first question here is, what are the possible quantum numbers for n is equal to 3? So let's take a look at this. If we know that n is equal to 3, what are going to be our L values? Remember that L is equal to 0 to n minus 1. So n minus 1, 3 minus 1 is 2. So it could be anywhere from between 0 and 2. So we'll have 0, 1, and 2. Okay. Now our next ones, our ML is equal to negative L to positive L. So if your L value is 0, well then your ML value will be also 0. Now in this case of 1, well, we can have from negative 1 to positive 1. So we can have negative 1, 0, and positive 1. So you can have 3 ML values for 1. And for 2, again, you go from negative L to positive L. So you can have negative 2, negative 1, 0, 1, and 2. Again, these would be positives there. So those would be your quantum numbers for that. And if you want to also talk about your MS, your quantum number for your electrons, remember that each one would have plus or minus a half. Okay, so you can have for this one, you'd have plus a half, you'd have minus a half, for this one, plus a half, minus a half, etc., etc. For all of these quantum numbers, you would have 2 possible electrons, one in the upspin, one in the downspin. Okay, so it says, which of the following are permissible sets of quantum numbers? So we have to use our rules and our possible values to figure this one out. So the first one is we look at n is equal to 4. Okay, that's fine. We have 4 energy levels. We have 4 periods. That's okay. Now, the possible values for L when n is equal to 4 is, remember that L is anywhere from 0 to n minus 1. Oh, well, this is a problem because if you can see here, L is equal to 4, you can either have 1, 2, 0, 1, 2, or 3, because 4 minus 1 is equal to 3. So the maximum amount of L could be 3. This is not possible, so this one is not going to be permitted. If we look at number 2 here, n is equal to 3. Okay, so that's fine. We can have that. L is equal to 2. That also makes sense because, again, it could be anywhere from 0 to n minus 1. Okay, and that works. 3 minus 1 is 2, so that's fine. The possible values for ml. Well, if L is, well, any value, ml will be equal to negative L to positive L. Positive L. So if L is equal to 2, the values for ml would be 2, 1, 0, minus 1, minus 2. Now we look at this ml value and it's plus 1, so that actually works. It's right over here. That's fine. And then we can also have a fraction minus a half. So actually this set right here, this set works perfectly. That's permitted. Now let's look at the third one over here. N is equal to 2. Okay, that's fine. We can have that. If n is equal to 2, remember that L was equal to 0 to n minus 1. So that actually works as well because it's 0. That works right away. ML, when we look at this one over here, remember that ML is equal to negative L to positive L. So if L is 0, that automatically is 0. So that works. The problem with this is that we have a 3 over 2 spin, which is not allowed. So this is not a permissible set at all. If we look at the last one, n is equal to 5, that's fine. L rests in the range from 0 to n minus 1, that's fine there. The values for ml, again, is negative L to positive L. If L is equal to 3, so that means 3, 2, 1, 0, negative 1, negative 2, negative 3 works. So negative 3 works is fine. And the last one over here is we have spin. Now there's nothing positive, no, there's no sign there, which automatically means it's positive. So this one is going to be permissible. Now it says list the values of the 4 quantum numbers for electrons in the 3D subshell. Okay, now it's telling us a specific subshell here. Now 3 again means your energy level. So that means that it's going to be quantum number 3. So n is going to be equal to 3. For the D shape, we have to look at what is our L value. Now if you remember, we have L values of 0, 1, 2. Those are the only possible ones for n is equal to 3, because remember, L is equal to 0 to n minus 1. Now if n is going to be 3, you can have 0 to 3 minus 1. So the only possible values for L you can have are from 0 to 2. So you have 0, 1, 2. Now 0 is equal to your S, 1 represents your P. So in this case, 2 represents your D. So your value for L is going to be 2. Now in this case, it doesn't give us a particular orientation, but so it could be any one of the subshells of D, but we have to figure out how many of those subshells there are. We have to find our ML. So remember that your ML is equal to negative L to positive L. So if your L value is 2, it can be anywhere from negative 2, negative 1, 0, plus 1, or plus 2. And then, because it doesn't really give us an orientation, it could be any one of these orientations. The only thing that we have to do is we have plus minus a half, plus minus a half, plus minus a half, plus minus 1/2, and plus minus a half. Because the electrons, all we're saying is it's saying the quantum numbers for our electrons in the 3D subshell. So it's just saying all the electrons, all the possible arrangements for electrons in the 3D subshell. So that means any one of the orientations and any one of the configurations for your electrons. All right, what is the maximum number of orbitals with n equals to 4, L equals to 1? So in this case, when we look at here, remember that the orbitals are going to be talking about the orientation of these orbitals. This tells us the shape. So 1 tells us that this is going to be p orbitals. So what we need to do is we have to find our ML. So our ML is from negative L to positive L, so it could be -1, 0, and 1. So here we have three possible orbitals, is +1. So we have three possible orbitals, so the maximum number of orbitals will be 3. Okay? Remember, this will relate to px, this will relate to py, and this will relate to pz. If we look at this one, n is equal to 2 and L is equal to 2, well, I wonder what's going to happen here. This, when we look at n is equal to 2, remember that L is equal to 0 to n minus 1. So in this case, this one wouldn't even exist. All right, so be careful with these questions. The only possible values for L are 0 and 1. So in this case, that does not exist. N is equal to 3, L is equal to 2. So L is equal to 2, we have to figure out what the ML value is. So the ML here, it seems okay. And when we look at here, the value for L is equal to 2 can fit with N is equal to 3. Because remember, L is equal to 0 to n minus 1. N minus 1. So that should be fine. 0 from anywhere for 0, 1, or 2. So ML is equal to negative L to positive L. So -2, -1, 0, +1, and +2. So here we have 5 different orbitals. If you really want to know, this will be your dyz, this will be your dxy, this will be your dxz, this will be your dz squared, and this will be your dx squared minus y squared. Okay, so there are different orientations. Again, you don't need to know this, but how many orbitals does it have? Maximum of 5. And the last one over here, n is equal to 5. Now here it tells us L is equal to 1. So L is equal to 1, remember, just like we saw over here, when L is equal to 1, that shows us that it's the p orbital. And here it actually specifies which orientation it is, -1 to +1. So it doesn't really matter which one you're going to choose, the px, py, or pz. We can just choose one because we usually say -L to +L. We're going to call this, we have three choices. We could say px, py, or pz. And because it's the first one over here, we're just going to call this px. So the maximum number you can have is 1. So in this case, which orbital cannot exist? So again, we have to look at the relationship between n and L. So for any n value, our L's are going to be equal to 0 to n minus 1. So if we look at the first one here, before we start, actually, let's just do, remember that our L values, we have 0, 1, 2. So this would be S, this would be P, this would be D, and if we had 3, that would be F. So for here, when we look at this, we can characterize this as this is going to be n is equal to 2 because that's your principal quantum number, that's your energy level. Okay, and our P, our L value, because this is a p orbital, if we go over here, that's going to be equal to 1. Now, does that work? Well, sure, because if we had 0 to n minus 1, 2 minus 1 is 1, so 0 or 1 you can have as your two L values, and sure enough, our L value is 1, so that works there. Let's look at 3p. 3p, so again, in this case, our n was going to be equal to 3, and because this is a p, our L is going to be equal to 1. So again, when we go into over here, L can be any value between 0 and n minus 1. n minus 1 would be equal to 2. Well, L is 1, so that works. It could be 0, 1, or 2, and L is 1, so that's fine here. So this is okay, that's okay. Let's look at 4D. So 4D, the n value, the energy level is 4. And the L value is going to be equal to, well, let's take a look. Our D's are equal to 2, so our L value is going to be equal to 2. Can this exist? Well, again, our possible L values is 0 to n minus 1. n minus 1 would, in this case, would be 3, and this fits right in. It could be 0, 1, 2, or 3, and this is 2, so that also works. 3F, let's look at this. So in this case, n is going to be equal to 3, and L is going to be equal, again, F here. Oh, that's not going to work for sure, because again, 0 to n minus 1, the largest value that L could be is 2. 3 minus 1 is 2. And this is L, so actually this one cannot exist. If we go to the next one, 6s, so again, our energy level is going to be 6, so N is equal to 6. Our L is S, so that is characterized by the L value of 0. And sure, absolutely, N can be, or L can be any value, 0, 1, 2, 3, 4, or 5, because N minus 1 is 5. And so in this case, S, 0, that's all good. So this one works. 2D, if we look at N is equal to 2 because that's our energy level, L in this case, because it's D, represents 2. So once again, this is not going to work because L has to be maximum N minus 1, so the maximum value could be 1, this is going to be 2, so this does not exist. Alright, in this case it says describe the orbital defined by the following quantum numbers. So in here, again, our N value tells us our energy level, and so that's going to be given 3. Now, 0 will tell us that this is an S, and because it's an S, it's a sphere, so it exists in the X, Y, and Z plane, so it's only going to be 3S. The second one over here, our energy level is going to be 2. Now, 1 represents a P, and here our ML, we don't really know which orientation is going to be. We know that ML can be negative 1, 0, or positive 1. So what we're going to do is we're going to call this, this could be PX, PY, and PZ. So we could say 2PZ if we wanted to, or we could just leave it as 2P, that's fine. This one over here, again, the energy level is going to be 4, given to you by the principal quantum number. 2 represents D, and this is going to be negative 1. So the orientations are a little bit more complicated. We're just going to leave it as 4D, and that's fine. Here, when we have N, that's going to be our principal quantum number 3. But the problem here, as you can see, the only values for L is 0 to N minus 1. So the maximum value could be 2. This is 3. This does not exist. And this one over here, when we go into the last one, again, our principal quantum number is 3, so our energy level is 3. This tells us, one, that this is going to be P, but there's a problem here again, because when we look at this, P can only be from negative L, which is 0, 1, to positive L, which is 1. Now this is the maximum value, it could either be negative 1 or positive 1. This is a value of 2, so again, this does not exist. Alright, thanks very much for watching. We're going to move it on. Thanks, and we'll see you soon. Bye.